Hello and welcome to my YouTube channel Engineering Fundamentals. So, in this video, we're going to learn about the concept of inductors. Now, what is an inductor? How do inductors work? How do they look? And where do we use them? These four questions are going to be answered in this video. So, by the end of this video, you should be clear with all these four questions. Right. Now, before we actually get into the working of the inductors and how do they look, let's see what an inductor is. An inductor is a passive electrical component. Now, there are two types of electrical components, passive electrical component and active electrical components. What are these? An active electrical component is a component which is capable of producing energy, such as a battery, a DC source or an AC source. Now, what is a passive electrical component? A passive electrical component is a component which cannot produce energy or which is not capable of producing energy but can store energy. A device which can store energy or can dissipate energy across it. Examples for passive electrical component are inductors, thermistors, capacitors, etc. etc. Now, we know what an inductor is superficially, right? Now, let's get into actually what an inductor is. An inductor is a device which stores electrical energy in its magnetic field. How does it store energy in the field? How does it supply energy to the load, etc., etc.? We'll get into that. Now, before we actually get into the working, let's remember two very, very important things. The first thing is Faraday's law of electromagnetic induction. What is Faraday's law of electromagnetic induction? Electromagnetic induction, or simply the voltage or the EMF that is developed across a coil or a wound conductor is directly proportional to the change in magnetic flux across the conductor. I hope everybody knows this law because this law is probably the most fundamental to explain all these components. Now, the second thing that we have to remember, it's more of an assumption or it's more of a probably a result. Let's keep it that way. Now, what is this? Always an inductor opposes the change in current through it. This is actually related to Faraday's law of EMI due to development of back EMF and all. Okay, fine. Let's get into that. I'll explain that too. Right. Now, let's get into the working of an inductor. Now that we know what an inductor is, and if we get into the working, I can actually explain to you how an inductor works. Okay. Let's start with working. Let me draw a circuit. Imagine that we have a light bulb. Please excuse me, my drawing is really bad. This is a light bulb. Okay. This is a light bulb. And we have an inductor connected in parallel to the light bulb. Then we have a source of energy, a battery, let's say. This is the positive, this is the negative terminal. Okay. Now, one thing that you guys have to remember is this is a voltage source, this is an inductor, and this is a light bulb or a load or a resistor. You guys have to remember one thing, that any load in the circuit acts as a resistor. So a resistor is automatically provided in the circuit. Right. Now, what did I say here? Always an inductor opposes the change in current through it. Let's get started. I have a battery and I switch it on, right? I switch it on. Current flows like this, it flows like this. At this juncture, let me name this juncture point A. At point A, current has two ways to flow, through the inductor or through the resistor. What did I tell you here? Always an inductor opposes the change in current through it. Initially, when the switch is, when the circuit is not closed or when the battery isn't on yet, there is no current in the inductor. So going by this law that an inductor opposes the change in current through it, there will be no current which flows through the inductor. Therefore, the current will not flow through this part and will flow directly through the bulb or the resistor, right? Okay.